All right. So yesterday there was a nice talk from CoreOS talking about the scale at 1,000 charts. So who wants to know what happens when we hit the 100K number? All right, perfect. So my name is Ankush Chadha. I'm senior solution developer at JFrog, and DevOps is my passion. And I've been in the release engineering and release management space for like past 11 years. I've seen the way from Maven and containerization, and it's pretty much fun. Like it's cool stuff. So let's talk about, so it's a different Helm chart. And so what we did is we are just trying to add the Helm repository via the Helm CLI. And we are tracking the memory, like how much memory is being consumed. So what we noticed is that when, it's not that clear. So, or probably to me. So when we had like 2,000 charts, it's doing pretty much well, like memory-wise. It was consuming like 12 MB. But when we hit the 40,000 mark, it was consuming about like 400 MB. And when it went over, like danced around like 100K mark, it was consuming more than a gig of memory, right? So when I'm running a container with a limited memory, then I'm not even able to add the Helm repo via the CLI, right? So that command fails. So the couple of questions to ask then. Define scale, what is the problem, and how to reproduce the problem, and how to solve the problem, which is the proposal. So scale, like one way to look at scale is the number of charts, right? By number of charts, I'm also including the versions within the chart, right? So a chart version can change if my application changed, or my dependency changed, or my deployment topology changes, right? So let's take a closer look. So this is a journey from source code all the way to my deployment on Kubernetes. So if my NPM package changed or my Maven package changed, my base layer changed, the way I'm Dockerizing my application that got changed, or maybe my deployment topology changed. Like maybe I'm adding lifecycle hooks to do graceful shutdowns, right? Or maybe I'm adding init containers to bootstrap my third-party services. So any change over here can result in a change to the chart version. So this was pretty interesting. So like with NPM, we can compare with other like recent new package types. So NPM beginning of 2015, it was like 12,500, and beginning of 2017 and end of 2016, it moved up like pretty aggressively to 400K charts, right? And the other interesting aspect of this is so there was a tweet by NPM a couple of weeks back this month. So what they mentioned is there were 4 billion package downloads that week, and the other interesting piece is the 12 billion package installs at that time. So the difference between the two numbers is the caching layer. So with 12 billion package installs, it also means that I have a variety of devices running my CLI. Like maybe my IoT devices or my edge nodes, which are low on memory. So like those edge devices, they have context of when my services will be updated, right? So there's a good reason or good use cases why we want our CLI to be running on low compute. So this was nice comparable. And as Docker is becoming popular, as Kubernetes is becoming more popular, microservice-based architecture is getting more popular, we'll hit this number pretty soon. So what is the problem? So the problem is the single index file per repository is not, it's a very good to begin with. Like I love the idea of simplicity to begin with, but it may not be I mean, it's not scalable like beyond a certain point, right? So the operations such as bootstrap, search, merge, like for us, the repository managers, one of the hardest things is like if the index file becomes like super big, any update operations, like say modification of absolute paths, any kind of operation becomes slow, right? So, this is the problem. And yeah, this was interesting. So how do we reproduce the problem? So we started like with a simple shell file. We Dockerized it, ran like multiple replicas of it on Kubernetes. Like, hey, okay, have fun, create a lot of charts, right? But like then to make it generally available, what we did is we implemented a sidecar pattern. So there was a main container which created all the charts, all the packages. And then there was a sidecar container responsible to pull the chart and push it all the way to Artifactory. And then we had a helper container, which what it did is it tries to add the Helm repository via the CLI, right? And by the way, all these scripts are public. I'm still working on the README. I just committed those scripts last week. Still working on the README, but they are public. So how to reproduce the problem is once we have the 100K charts, and when we just to try running like a container with low memory, we are not even able to add the Helm repository. So the proposal is there are a couple of ways to solve the problem, right? So one way to solve the problem is to have an index per chart version, which might be an overkill, like it's seriously an overkill. Then the size of the index, how to control the size of the index. Like few package managers, what they do is they compress the file on the server side, and whenever the client is requesting, they send over the compressed version. But then in this case, it won't solve the problem like quite well. So the popular partitioning technique is to have nested indexing, where the top level file, my index YAML, it only includes the chart names, and that's it, right? And then I'll have subfolders based on chart names, and then I'll have the sub-index files. And those sub-index files, they're also structured in a way that I talk about the latest, and then I talk about all the versions, and maybe we can push even the metadata, like the description, the GitHub URL, the authors, even further down at the chart version level. So yeah, that kind of summarized my talk. So this is a proposal that we want to share for Helm 3, and we really want to make it successful. Thank you.